Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Abid to Professor Madya, Dr. Suraya Muhammad Tahi and my fellow friends. I am Nur Izan binti Bajuk. My matrix number is 190952. So today, I would like to share with all of you about a powder metallurgy production route of stainless steel handle. Before we go further on how this metal handle can be produced by a powder metallurgy method, we need to know what is a powder metallurgy method is. Powder metallurgy is a processing technology in which parts are produced by compacting and sintering metallic or non-metallic powders without passing through the molten stage. This means that this powder metallurgy process does not require any melting process in order to get the product. So basically, this is a production sequences in powder metallurgy. First, we start with powder production, blending the powder, compaction or forming, sintering, and lastly is finishing or known as a post-sintering as well. So for this case, for this task, we are required to choose any product with their current production method. So I decided to choose a handle, a metal handle as a product, and these three are the current method for their production. First is a roll forming. Standard, what is roll forming? Roll forming is a standard procedure in steel parts production. This method are usually being used when we use a steel as a product, and the sheet steel will be bent or rolled into a required shape by using a machine. And next, tubular hydroforming. Tubular hydroforming is a liquid pressure to form tubes made of stainless steel in the shapes needed for any products, and it also provides excellent properties in bending and rigidity while using a minimum amount of stainless steel materials. And next is tubular stamping. Tubular stamping, or known as a tube stamping, relatively new material of stamping that can be used to produce more complicated tubular parts for a variety of applications. For these two methods, it is quite similar, but the differences is tubular hydroforming is for more simple product, but tubular stamping is for more complicated product. So now we move on to the powder metallurgy routes of stainless steel handle. First step. This is the crucial step for powder metallurgy method. That is powder material selection. Any element from the periodic table contained at room temperature and above in a solid state can be formed by chemical, mechanical, or pyrometallurgical can be used as a powder. That means any element that present in the periodic table that can be formed as a solid can be used as a powder, such as copper, aluminium, iron, titanium, and etc. So the compacting powder blends are made from the three types of powder, which is mixed metal powder, partially alloyed powder, and pre-alloyed powder. We know that every time we want to use a powder metallurgy, we need to have a good powder as a base, and basically we use a mixture of a powder with a different element in order to enhance the mechanical properties for the product. So as you know that I already choose a stainless steel as a material, and why I choose a stainless steel for this product is because this stainless steel are well known for its resistance to conditions including rust, grip, and high temperature. and it's also robust. It's a strong material, simple to use and represent an attractive finish. As we all know, stainless steel is a material that do not easily to get rust, and it can withstand the high temperature. So this is a good properties of material that can be used for this metal handle. So now we move on to the how we want to get a stainless steel powder. So this is three method in order to get a powder, metallic powder. First is atomization, chemical and electrolytic. For this case, I choose a water atomization in order to get a stainless steel powder. So first step, the stainless steel is normally heated and the liquid metal flow into orifice. Okay, and then the high pressure explosion of gas will blow to the orifice, and then thereby separating the molten metal into fragments that rapidly solidify. Fast speed gas stream flows through an expansion nozzle, siphoning and pouring molten metal from below into a container. And then the droplets, these droplets will solidify to form a powder. So this is the how the stainless steel, the raw stainless steel can form into a powder by using atomization. And the second step is a blending or mixing powder. Blending is a process where powders of the same chemical content but probably different particle size are mixed together. Whereas mixing is a process is when the powder are mixed in various chemistry, and the process of the powder metallurgy allow various metal to be combined into alloys. So this blending and mixing are quite similar, but the difference is the powder, the content of the powder is different. For blending, it has the same chemical content, but for mixing is a various chemical content. And why this blending or mixing powder process is needed? Because we want to have a powder that well homogenized, and also we want the powder have a low percentage of porosity. That means the the porosity is low, and the density of the powder is get high, because the it will get tight very strong. And then basically you can see here how the mixing or blending process are working. And for this process, blending or mixing process, we will add some additive in order to enhance the chemical properties of the powder itself. So for example, lubricant, binders and deflocculants. Lubricant is for to reduce the particle diffraction, because we want the product is easily can remove for the end product. And then the binders to achieve enough strength before sintering, and deflocculants to improve the flow characteristic during feedings. And this is common and different equipment geometries used for blending powders. This is a cylindrical, square shapes for mixing machines. And next, third step is powder compaction. Powder compaction is a method of compacting metal powder by adding high pressure in a die. And the instrument that we use usually kept in the vertical direction, like this, vertical direction, with the punching tool surrounding the bottom of the cavity. And usually its required pressure range from 70 MPa for aluminium to 800 MPa for high density iron. So this is the step for powder pressing. Cycle will start charging or filling die with powder, and then compaction begin. The process of compaction begin. Compaction completed when the pressure push from upwards, and then ejection part and recharging die, means the cycle will goes on and on like this. You can see the videos how the powder pressing are working. Okay, next, after the process of powder pressing, we want to improve the density distribution of the powder. So there are a few methods that usually been used. For example, cold isostatic pressing or hot isostatic pressing. And for this case, I choose cold isostatic pressing to make the stainless steel metal. So basically, cold isostatic pressing will start with a powder that been placed in a flexible rubber mold. This is flexible rubber mold, and the gray one is the powder. And then surround of the mold, there are water that will be pressurized hydrostatically in a chamber. Means all water will pressure and attach to the mold and compact the powder itself. So you can see here, this is water filling around the mold, and then when it's full, and it will be pressurized hydrostatically and compress the mold itself, and it automatically will compress the powder as well. So the fourth step is design consideration. Design consideration, we start with a tooling selection. As we know that we use stainless steel powder, and it considered as abrasive. So we don't want this stainless steel powder will affect the materials. So we use a carbide as a tooling material. So, and then for designing the tools and dies, we want to make sure that the part can be easily removed from the die, and we don't want we want to prevent overstretching device component, and also to avoid crack during ejection. That's why tooling selection is important in order to eject the parts safely. And then we move on to the classes in powder metallurgy part design. There is 4 classes or 4 types of powder metallurgy part design. First is class 1, short and clear form, push from one direction like this. It's a simple product or simple shape. And next is a basic but thicker types. Thicker types require two-way pressing. And next is class 3, 2 thickness stages. We have this one layer, and second one press into direction also. And next is category 4 or class 4 is several thickness stages. several thickness stages, and press from two directions as well with different control per stage. And for this case, our product, the metal handle, from class 2, basic but thicker type, require 2 ways of pressing in order to eject the product. So now, as you can see here, this is the metal handle. Okay, we, for designing, we avoid the side undercuts, because side undercut means the edge of the design. We want to avoid any design that have a sharp edge, because it will difficult to be cut, so that we can change it to a chamfer design. I mean the chamfer design, in order to reduce the rough point and assist in extracting burrs. So we can avoid extra burrs. So the angle of the chamfer used is 45, basically is 45 degree with a large radius along it. And as I said before, any sharp edges need to be avoided in order to prevent risk of cracking the tools. So we have this chamfer shape and long radius, and also inside radius. If the larger radius will increase life of core roots. So if we have a sharp edges, it will have a risk for the parts will be easily get cracking. Okay, next we move on to a fifth process, which is sintering. Sintering is a loose metal powder or green compact, which is a powder that not completely done yet, that been compressed under regulated time and at a temperature below its melting point into the appropriate composition. And the use of high temperature sintering result in greater resistance to corrosion and mechanical properties. That means in sintering process, we need to use a high temperature in order to have or to get the resistance to corrosion and enhance the mechanical property itself. So this is basically the step in sintering process. First is preheating, and next high temperature stage, which is to form the diffusion bonding, solid state bonding, and then we will refrigerate in a controlled atmosphere, in a atmosphere temperature, in order to avoid oxidation and thermal shock. Okay, next is a secondary or post-sintering process. Basically, after we done the sintering process, we will continue with a post-sintering process, or we can set it for a finishing process as well. So process either coining, repressing, sizing, deburring, plating, and others. It depends on the product itself. So for stainless steel handle, it will undergo the deburring process in order to remove excess burr after previous process. So basically, you can see after a compaction, there will be extra unwanted materials, unwanted parts that been left after the compaction process. So we need to remove it. So this is we call as a post-sintering. And next, finally, we undergoes the plating process, which is plating used for decorating object, enhancing solderability, hardening, enhancing wearability, minimizing friction, improving paint adhesion, altering conductivity, radiation shielding, and other uses. So basically, the plating is for finishing step in order to get attractive product. So now we move on to the advantages of powder metallurgy compared to other methods. So basically, powder metallurgy is a method of forming close to null shape, meaning that there will be no or only a few finishing operations that needed in order to complete the whole process of powder metallurgy. So similarly, the dimensional precision is very high when we use a powder metallurgy method, so that for the end of the product, it will not take a lot of finishing process in order to get a good quality of product or the end product. So next, the cycle yields very little scrap compared to casting and forming process, where the scrap will be more during the process of compaction and finishing. And this will increase the cost of production and increase the number of waste of scrap. So we can compare it between powder metallurgy method and other process such as casting or forming. We can see when we use casting and forming, there will be more excessive scrap compared to when we use powder metallurgy method for the production. So this will increase the cost of the production when we have more excessive scrap, and it automatically will increase also the number waste of scrap. So we need to change the powder metallurgy as a method that can be used in order to save the cost of the production, and we can also increase the rate of the production itself. So next, the other advantages is time taken to engage from principle to manufacturing using powder metallurgy is always very limited, with economic benefit compared to forming or casting process. Because we know that when we use a powder metallurgy, we can reduce one process, which is finishing, because we know that some cases or some product won't take any finishing process at the end of the whole process, because this method forming closeness to shape, so there will be no finishing process needed, so we can save the time, save the cost for the production. So for the conclusion of this presentation, the powder metallurgy process offers a rare ability to cost effectively manufacture. So we can see that this powder metallurgy is basically can help the company to save the production rate, production cost, save the production cost. And then this powder metallurgy is one of the most versatile technique to produce near net shape component. And also we can see there are more advantages for if we use a powder metallurgy compared to other process method. So with that, that's all for me. Thank you.